Good morning, guys. Yeah, I'm super excited. How many of you guys have used Unity before? Or is this going to be kind of your introductory course? That's pretty cool to hear. Well, I hope by the end of this, you guys can get hyped up and maybe create a game for your hackathon. What we're going to be building today, and this is just a little sneak peek, it's going to be a game where you're avoiding the enemy blocks that come to you. So these blocks will be raining down, and we're going to be avoiding them with our player. Our player is the red dot there. It's a very simple idea, but it's gonna be a good way to see not only how to move the player, but also how to interact with multiple objects in the scene. We will wait 5 minutes so everyone gets here, but yeah, super excited, guys. My message sent twice, but yeah, we'll just be waiting until 9:05, and we're gonna build a game. All right, welcome to the people joining in. We're about to start. We're gonna make a simple game from scratch, and this is gonna be a good way to get you started. If by the end of this you're interested in building more things, I can send you the resources as well. The good thing about Unity is that it makes it so easy to build a game really quickly. So it's like, if I was gonna make my own game for a hackathon, I would definitely use Unity. Especially as a beginner. It's very beginner friendly as well. Yeah, since I still see some people coming in, I'm gonna wait a little longer. Oh, by the way, if you guys want to follow along, that's totally fine. You will need to have Unity installed. I assume that if you want to follow along, you already had it installed beforehand. If not, you can try installing it right now. It just takes like 20 to 30 minutes, the whole process. So if you don't really have it, maybe you're better off just watching and like learning from it. However, you can definitely try and download it. All right. I think it's about time. I'm gonna get started. So yeah, I mean, this is the Unity launcher. This is where all your projects are gonna be there, and this is just a test that I made a few seconds ago. But let's make our game for this workshop, right? So the name is gonna be Avoid the Enemies. And I want this game to be a 2D game. But as you guys will see, the differences between 2D and 3D are very small. Now you can actually start a game as a 3D project, but then modify it so it's 2D. It's completely fine. But yeah, I'm gonna create it. And yeah, it takes a little while to create a new project, so I'm just gonna wait. Yeah, I'm excited to see that some of you guys have used Unity before. For the people that came in later, this is the game that we're planning to build today. It's going to be a very simple 2D game where we have blocks falling down. It's 2D. For this project, it's 2D. Thank you, Paul. Yeah, we're going to have a few blocks falling down, and then we have to avoid them with our main player. Our player is only going to move horizontally, and if we move outside the map, it's going to wrap around in the other side. So that's something that's going to be cool. But yeah, guys, so as you can see here, this is your main. Just give me 1 second. As you guys can see here, this is the main screen for Unity, right? And you guys are going to have a hierarchy here on the left, then a scene. This is where you actually put all the game objects and everything. Then you're going to have the way that it comes by default is like this. You have a hierarchy, a scene, and with a game tab, I just grab the game tab and I just move it to the right so I can see my game as I'm developing it. And then you're going to have a project tab on the bottom, followed by a console. I also like to have my console on the right so I can also see the console output. So to answer Paul's question, when you download Unity, at least in Windows, it also automatically downloads Visual Studio, the Visual Studio IDE. So you don't really have to worry about anything. I am not quite sure anymore how it handles it with Mac, but I know that before, like a couple of years ago, it just downloaded a proprietary text editor for Mac. Maybe it does VS Code now. I really don't know. I haven't used a Mac in a while, but so far Unity downloads the text editor when you download the program, so that should not be an issue. So as you guys can see here, this is a 2D game. But what does a 2D game mean? Well, if you see the main camera on the right, oh, by the way, I hope you guys can see everything. If it's blurry, please let me know so I can make the screen bigger. Let me try right now. Maybe it's too big though. Would this be too big? I think that's more legible. So yeah, if I press the camera here in the hierarchy, I'm gonna see a setting that is very important here. It's called orthographic projection orthographic. If you set it to perspective, then what you end up having here is a 3D game. Thank you, Alexandra. The only difference between a 3D and a 2D project, for the most part, is just the projection is gonna be perspective for 3D, and then this tab here for 3D is disabled. So if you press 2D and you don't press it, that's the main difference. So what does orthographic mean? Well, if I add a cube, and by the way, to add a random cube, you can right click here in the hierarchy and then find the cube object, or you can press the plus button and find the cube object. Okay, so this is my camera and this is my cube. As you guys can see, my cube was spawned in a very random place. And that would be very annoying to just set it up. And anytime you spawn something in the hierarchy, it's always gonna spawn in a random place. Something that's very common to do is you just right click the transform attribute and then reset. And then that's better, right? So if we go close here, this is our camera. Okay. So what happens in perspective view if I get closer to the camera, the object appears to be bigger. This is how 3D games work, right? But if I go here and set my camera to orthographic, the distance, no matter how close I am or how far I am from the camera, the distance is always the same, and you see the difference here. So yeah, that's the main difference between a 2D and a 3D project. For now, we're just gonna do a 2D project. And since I basically, and I mean, you guys can see, let me delete this. If you create an object here, cube, let me call it player, and then on the transform, I reset it, then you guys can see, like, here is the scene, and this is how it looks in the game. Now, I want my game to look like this instead, like how I showed you guys. I want my game to look like this instead. Like a rectangle that goes from the bottom to top, right? A vertical rectangle instead of this horizontal one. So what I'm gonna do for this is just here in the aspect tab, I can create a custom aspect, and I'll make it. Let me check again what aspect ratio I used. Well, it should be aspect. It should be 3x5. Okay. So yeah, 3x5. Okay. Aspect ratio instead. 3x5. There you go. So it looks more like a mobile app. And we have our player here. Now, I don't want my player to be in the middle. I want my player to be lower, like we have here, right? So you can either click on the object and then press shift. So whatever you move, it's only in one axis. However, when I'm moving this, I don't know if you guys can see up here in the transform, how by moving my object, it affects the transform, right? So for example, I want my object to be in -4 here, -4. There we go. Now, that's all fine and dandy. But what if I want to be able to move my player? I mean, that's one of the main things, the main features of this game. Well, let's think a little bit before we get started on how we're actually going to move this player. I mean, you guys already saw that we have this transform attribute, and if I'm moving it by hand, those values change. And the values that change is either the X and the Y, because we're only in 2D, right? So we're only moving this cube in the X and Y axis. So we have to find a way to actually change these values, but instead of doing it by hand here, doing it with our keyboard input. Well, Unity already has something set up for us, which is kind of great. And you can see it in the project settings. Oh, let me try again. Project settings and then input manager. Yeah, here. So Unity already has a system to actually get our, our keyboard input, and it's called the input manager. So horizontal is going to get the input from our left and right keys. And then vertical is going to get the input from the up and down keys, right? And those are either our, A, D, or the actual physical arrow keys. Both of those should work for this. But yeah, just keep in mind this horizontal and vertical names, because that's going to be brought up later on. And yeah, another thing that we need to remember for moving our object is just the basics of how, how we're going to actually handle this movement. So we know that speed is just a number of meters traveled per second, right? If we want to use meters per second. That is our speed. However, if I want to have a velocity, it's going to be this speed times a vector. What is the vector? Well, this vector is going to be the direction we want the player to move. So imagine I press the up key. I want my player to move, in the direction of up at the speed of 12 meters per second. However, the way games work is you're rendering the game frame by frame. So every frame, you want to move a little bit, a little bit, a little bit. You're not really moving the whole amount every frame. You're just moving a small amount every frame. This is where the delta time property in Unity comes in handy, because it automatically detects at what frame rate your game is running at, and it allows you to have this velocity changed. Instead of having the whole value for velocity, it just changes it into a small value that's going to be enough for every frame. So what's going to happen is, if I press the up key, this object is going to be moving every frame a little bit, a little bit, a little bit, a little bit, a little bit. And once a second is complete, it's going to have moved like 12 meters in that second, if we decided our speed to be 12. So yeah, I know that can be a little confusing for now, but I feel like it's going to make more sense once we actually program it, right? So yeah, let's get started with that. So yeah, whenever you want to grab an object and make it do some sort of function with programming, you have to create a script for that. So I'm going to go here to my project manager here, and I'm going to right click and then create C# script. This is the language that is used in Unity. It's C#. And I'm going to call this player movement. That's great, right? Now I'm going to select the player here. And then you're going to see all the attributes of the player. It has the transform, all these things. Well, I'm going to grab my player movement, and I'm going to drag it to the player object. Now we have a player movement script, and you can click it right here to open it. And as you can see, Visual Studio opens up. Isn't that great? So yeah, we want to make our player move, right? So let's get started by yeah, just 1 second, guys. Let's get started by actually just making our player move to a random position. I mean, just so we know how to actually interact with the transform property. I'm gonna know that if I want my player to be up here, I'm gonna need to set the position Y to be 2.5 or something. So how can you do this with code? Well, you can access the transform property of the object by just typing transform, and then the position, which is this section of the transform property, position. Now, as you can see here, the position value is a vector, right? It has 3 axes. So if you want to set a value to it, you need to create a vector 3 and then input the values in it. In my case, I'm going to have 0 for x, 2.5 for y, and 0 for z. For z. Yeah, I'm just going to save this. And the way that you run code here is you just save it in Visual Studio as if it was a text editor. Oh, argument cannot be converted from double to... Okay. So, yeah, I forgot about that. Whenever you use decimal values in Unity, you have to end the number with the F, so you can tell it that it's a float. That was my bad. So yeah, once you save that and then you're able here to run it, you're gonna see that the cube moved upwards. So yeah, we were able to actually make our cube move. But yeah, that's still not very interesting. I want to be able to move it with my keys, right? So yeah, let's get that working. I'm gonna get rid of this, and okay. I guess you guys can already tell. I mean, it's literally written here, but the start function happens only once once the object is created, and then update happens and every frame after the object is created. I want to detect my input from my keys every frame, right? Because if I press the up key, I want to be able to detect that right now. So vector 3. Yeah, I'm going to create a vector 3 variable called input. And then the value of this vector 3 is going to be... By the way, guys, if you guys have any questions, let me know. You can access the properties that I showed you guys before by using input.get access raw. And then you type horizontal. And this is what I showed you guys before. Remember, horizontal and vertical. This is why it's great with Unity. For my x-axis, it's going to be horizontal, and then my y-axis is going to be input.get access raw vertical. And then finally, for my Z axis, it's just going to be 0 because we're in a 2D game. We're not really moving in that axis. And then I want to just be able to print it. I want to print so we all can see like how the input changes whenever I press my keyboard. So yeah, let's just run this. And I have more errors. Let me check it out. Input. Okay, so this right here is capital because we're accessing the input class. Perfect. So if I run this right now, it's printing the keyboard input. And if I move my key to the left or to the right, you can see how it's affecting these vector values. So yeah, let's use that to actually move our cube, right? So what I'm gonna do, and it goes back to what I showed you guys here goes back to what I showed you guys here. We're gonna have a speed, which is, the speed that we want the cube to move. Then we're gonna have a vector for the direction. Well, the vector for the direction is gonna be the input that we get from the player. And then we're gonna multiply that by, we're gonna have a speed multiplied by the direction and then multiplied by delta time, so we can get the value that the cube should move every frame. So thanks, man. Yeah, this is not very complicated physics, but I'm super happy to see you here, man. So yeah, let's just get into it, right? Vector 3. So our direction is going to be input.normalized. And you may be asking, why is it normalized? Well, if you actually happen to press the up key and the left key at the same time, the player is going to move faster than if you just press the up key by itself or the left key by itself. That is because the way it's going to work, and it's hard to explain, but the actual size of the vector, it's going to be longer if you have both keys pressed together. So by normalizing it, you're making sure that the vector can never be longer than just one unit. That was very rough explanation. But yeah, it's just to avoid, because if you didn't do that, then your player and everyone that plays your game would just run sideways, because that way they run faster and maybe they can get an advantage. Vector 3, then we're going to handle our velocity, which is the speed times the direction, right? So speed times direction. And finally, we don't have a speed defined. So a cool thing about Unity is that if you define a variable up here as public, what happens in the IDE is you end up with an error. Let me check it out. Okay, invalid token, member declaration, floats. Oh, okay, yeah, of course. Silly me. You have to define the type. If you define a variable as public, then you can access it through the Unity interface, and you can actually change that as you're testing the game. This is great for prototyping and just developing what values make a good feel for your game. But yeah, that's going to be my speed. And then finally, we want to know how much we want to move every frame. So vector 3, the move amount, is going to become velocity times time.delta time. Finally, and I know you guys saw this before, how do you access the transform property here, transform position property? You're able to just reference the transform from the object that you're in and the position inside it. And I'm just going to add every frame that little bit of move amount. Let's test it out. It compiled this time without error, so that's good. So now by pressing my keys, you guys can see how I'm moving this. So that's how you would handle the most basic of movement for 2D games. And it's really the same for 3D as well. In 3D, you're not really moving 3 axes at once. You're not really moving 3 at once because usually that other one is going to be for a jump or something, right? You're going to press the space bar and it jumps. Another way to write this, and it's actually more common than this, is just to do transform translate. And then you put the value, move amount. It does the same thing. So if I try that, and I press the cube, then it's gonna move. Well, yeah. So we got that working. If you guys have any questions, just let me know. But let's get started with implementing one of the features that I told you guys about, right? So if my block moves all the way to the right, if it moves all the way to the right, I want to be able for this block to spawn on this side. And if you guys see here, when I move all the way to the right, my block is in the position of 3. And if I move all the way to the left, it's in -3. So let's keep that in mind, right? And we're gonna do this like this, right? So for now, I'm just gonna define a variable called float screen half width. And this is gonna be 3. Because every time I move, like from this half is 3 units, and from this other half is 3 units. So the entirety of this is 6 units, but just the half of it is just 3. And you guys can see, since the actual camera is centered in the center of the world, by moving to this side, you go to the negative positions, and then this side is positive. So before actually setting this right here, right, I want to be able to actually, let's do something. I have the transform.translate, so my block is going to be moving. However, if my transform position x is less than screen half width, I will send my block to the other side. Transform position the x equals, and I'm going to create a new vector. No, actually the whole, well, I could technically do this. Just the x value and then screen half width. So what am I doing here? If my position is less, oh, actually it should be like that, because when we're in the left side, the name transform does not exist in the current. Yeah, I mistyped it somewhere. Transform here. Transform position, because it's not a variable. Yeah. So you cannot really use it like that. You have to create a new vector for every time. I'm going to create a vector 3. Doesn't really matter. Well, you could create a vector 2 since we're only using x and y, and then screen half width, transform position y. So, oh my god. So yeah, guys. If my block is going all the way to the left, the value in the position of x is going to become greater. Sorry. It's going to become lower than -3. So what I'm doing in the code is I'm detecting if the position x is lower than -3, because screen half width is just 3. Then I want to set my new position to be positive screen half width. So it's going to go here to the right. But the transform position y stays the same, because I don't want my block to move up or down. I want it to stay in the same y position. So if I do this and I go and I move left, you guys can see how the block is appearing to the right. I can do the same for the other direction, like else if transform position x some reason I'm not getting in like IntelliSense on Visual Studio right now, so it's a little harder. But screen half width, and then transform the position the x. My bad, new vector 2. This is gonna become negative screen half width, and then transform position the y. Yeah, this is just the same that we did before, but for the other side. And now, technically, if I move left or right, I'm able to teleport. But as you guys can see, it's kind of like a jump. It's not really smooth. Why is that? Well, as you guys can tell, my block is just. I am saying that I want to move to -3, but in reality, I should do -3 plus half the block width, because my block is just, half of it only goes there. I need to add another half to that. So for now, I'm just gonna add here. Wait, I guess it should be here. Screen half width. I'm just gonna add 0.5, because the default block is just 1 unit. So if you add 0.5, technically it should work now. Yeah, now it's like a more smooth transition, right? If you want to try out, yeah, 3.6 also works. But at the end of the day, this is not a really good solution, because what's going to happen if my block becomes slimmer? Then all of this throws it off. What's going to happen if I change my aspect ratio to something else? This right here is a bad way to approach this. And I'm going to show you guys like what a better approach to this will be in a little bit. So yeah, actually something you can access with Unity is the current camera aspect ratio. So our aspect ratio right now is 3/5, 3:5, right? Now, something to keep in mind, we can access the aspect ratio and also the size of the camera, which is here, camera size. You guys see? My aspect ratio is 3:5, and then the size is 5. So if you do a simple like question like this, you know that the camera size is actually the screen height. So by multiplying the aspect ratio by the camera size, you actually get the width in world units. So by doing that operation, no matter what this aspect ratio is, we're going to be able to have an accurate like function of moving left to right. So let's implement that in the code and let's see what it would look like. Just give me 1 second, guys. So yeah, now I'm gonna remove the variable that I set up there, and instead in the start of the, at the start of the game, I'm gonna declare this variable to be camera dot main dot aspect. This is how we access the aspect ratio, and then we'll multiply by camera dot main graphic size. Yeah, man. And then I'm gonna add it by half player width. Now, what is half player width? Well, we're gonna define it here as well. Float half player width. It's gonna be transform the local scale x over 2f. So if you guys can see our local scale in the player, let me see. Let me show you guys. The local scale of the player is how we actually define how wide it is. And the default cube is 1 by 1 by 1. So I can actually access this value here. And if I want to get half, if you want to get half the width of the actual player, you just access this value and divide it by 2. And this is what we did here. We access the local scale x and divide it by 2. Man, Zachary, we're gonna become rich making 2D games, I'm telling you. And hi, hi, Athena. But the fun thing about it is, like, I'm teaching you guys how to make a 2D game, but like the concepts are very similar for 3D as well. So yeah, now that I have this, my code should actually be a little more ready to not only, like, if I change this, but also if I make my player super wide, it's still gonna work. Oh, well, let me test something. Let me see what that's happening. Okay, let's check it out. So our half player is transform the local scale x over to f, and then camera orthographic size plus half player width. No, man, I'm telling you, the debugging. Main aspect, camera main orthographic size. Okay, well, this was working yesterday, so now I'm depressed. But you guys get the idea, right? There's probably something small I'm missing. But just so we can continue with the workshop, I mean, that's just some small little detail. It still works fine. I guess, oh, I can tell you the problem right now, because I was doing this at the start, and I changed the width of the object in the middle of the game. So if I wanted to be able to change the width in the middle of the game, I would have to define this in update. So if I define that in update and then I move it, and I can change the scale and make it extra wide, and then it's still gonna work. You guys see? Yeah, that was a mistake. Silly mistake. But usually I mean, our game wouldn't want to change that on the fly, but you could. So that's something to keep in mind. Now, I'm gonna, because we have 20 minutes left and I really want to get the enemies. We're gonna make some enemies that fall down, and we have to try and, avoid them with our game. So in order to create, I mean, think about it, guys. We're not only gonna have one enemy, we're gonna have a lot of enemies, but they're all based on the same enemy object. So something that you can do with Unity is create prefabs. And a prefab is basically like this object that has, some model in it, some properties, and some code. And you can use it and put it as many times as you want in your game. Actually, you can make a script that automatically creates that prefab into the game and eliminates it as well. So let's do that, because, okay, yeah, here. I'm going to create a 3D object. This is also going to be a cube, but I'm going to call this enemy. Also, I want to make my player a little slimmer, like that, 0.2. Because if not, it's going to be a really hard game. But yeah, the enemy, always, I like to just reset my transform so it's centered. And I'm going to create a C# script called enemy movement. Yeah, and I did a mistake here. This script, I did lowercase in the beginning. You don't really want to do that because it's not convention. You want to do uppercase in the beginning as well. But yeah, I'm going to grab my enemy script and I'm going to put it to my enemy object. So you guys see now when I click my enemy object, it has this script here. So we can open it, right? Let's make an enemy that when it's spawned, it just moves down. That's the whole job of the enemy here. So how will we go through making that happen, right? Just think about it. As we did it before, we were taking the player's input. However, this time we don't really need the player input to control the enemy. What we need is to, well, we're gonna set a speed because I want to be able to change the speed of the enemy. Float speed. This is gonna be, I don't know, 7. And transform. By the way, 7 is gonna mean at the end of the day 7 units, world units per second. What does a world unit mean? I don't know. Whatever you want. It could mean meters, you know. It could mean feet. Depends on how you build your game. Transform. Translate. I mean, we saw this before, right? But instead of translating it with my player input, I'm just gonna use this vector 3 dot down. What does vector 3 dot down mean? This is gonna be a vector 3 that has 0, -1. No, it's gonna, yeah, 0, -1, 0. That's all it means. Then we put speed here. Speed, and then we multiply by time dot delta time. So yeah, I have this in my enemy object. What happens if I click start? It falls down. That's great. We want it to fall down. But is that really that useful? I mean, if I have a game where with only one enemy that falls down, that's not really fun, right? I mean, that would be a pretty easy game. So I want to actually create another script that is going to manage my enemies. A script that's going to spawn my enemies pretty much up here in random spots so that I can avoid them. Well, before I do that, now I know that I have this enemy object that I like. I can actually grab it and put it in my project. And then that's how you create a prefab. So now I can actually delete the enemy and I can put as many enemies as I want here. And since it's just a prefab, they're all gonna act the same. All gonna act the same. And if I spawn this right now, we're just gonna have 4 enemies falling down. Again, still not very useful, right? We want to be able to have that done dynamically. So yeah, let's think about it, right? How are we gonna do this? Well, sometimes you can create objects that are not really physical objects. You can create empty objects like this one. And this is actually not gonna do anything visual. It's just gonna be handling our script. I'm gonna call this enemy spawner. Again, it's good to reset the transform. And yeah, what am I gonna have inside? Well, I wanna have a script, right? It's gonna be spawner script, spawner. Then I move my script into the enemy spawner. And then I open the spawner script. So what are we gonna do inside of here? Well, first I wanna create a reference, and this is gonna be public, to my prefab. So game object, and then it's gonna be enemy prefab. Now in this script, I'm gonna have an option to give it the prefab that it's gonna use. So by giving it, and you'll see how easy that is. By giving it to that, now I'm gonna be able to actually spawn that prefab anytime I want. Now, where am I gonna spawn those prefabs? Well, I want them to be spawning here on the top. And to do that, we're gonna have a similar approach to what we did before with like handling our player so it doesn't go out of bounds. Well, let's handle our enemies so they spawn inside the bounds, if that makes sense. So I'm gonna create a vector tool here. vector 2 screen half size, just like we did before. And how can the team edit the program all at once in real time without paying a fee? If you sign up for the Unity student option, there is like collaborative features with up to 4 people. So that may be something you're worth looking into. And it's free for students. So screen half size is gonna become a new vector 2. So the X, which is the constraints, right? The constraints that I want my enemies to spawn in. We're gonna do the same thing we did before with the camera, the main, the aspect times camera, the main, the or always kills me typing this orthographic size. Now, something that you may realize is that the height of the camera view is the orthographic size. This is 3 by 5, and 5 is the orthographic size. So I can use 5 as my Y value because I want my enemies to spawn up here. So I'll just do that now for my Y. That's just gonna be handled at the start, and then every time I update, I want to create a new vector. There are 2 called spawn position. This is gonna be a new vector too. Property that you can use. It's random dot range with Unity, and this is gonna give you a random number that is in between the range that you give it. So what's a range, right? Well, a range goes from minus screen half size X to screen half size X. And our Y is always going to be screen half size Y. Why did I choose a random value for this but not for this? Well, I want my enemies to spawn randomly in the horizontal axis here, but I want all of them to spawn up here. I don't want them to spawn in the middle of the screen. I missed a semicolon here. Finally, I mean, this is all a little, hard to read, I guess, but finally, we're actually going to be able to spawn our prefab. So you do that by instantiate. You tell it the game object that you want to, instantiate. In that case, it's going to be the enemy prefab. You give it a position, which is going to be our spawn position. And then you're going to give it a rotation. But for now, we're not going to care about that. And if you want to spawn an object with a rotation, just 0, the rotation to be 0, you can use quaternion the identity. For now, you should not worry about quaternions. They're a very interesting math topic, but you don't need it for this basic game. So yeah, let me see what happens. Did I miss another semicolon? Yeah, I did. I've been programming with Swift too much. I'm getting used to not using semicolons. Okay. So what happens now if well, we are getting enemies, but as you can tell, we're getting 1 enemy every frame. This is crazy. This is gonna make your game crash because we're also not deleting them after. So they're going infinitely down. You see that? If you made this as a mobile app, I don't know, I imagine your phone will overheat or something. So we actually wanna constrain this to happen once every certain amount of time In my case, I'm gonna make it to spawn once every half a second. So let me define a variable here called public float time between spawns, and this to be 1, right? And then float next spawn time. This one right here is something we're gonna use as well. You'll see. So every time the update hits, I want to check if the current time, which is time dot, oh my god, am I not gonna be able to type that? Time but okay, there. Time dot time is greater than next spawn time. So what's happening here, right? Finally, next spawn time equals time dot, oh my god, time dot time plus seconds between spawns. No, time between spawns. Okay, so at the start, I'm gonna define this to be 0. So that's fine. So the first time, the real time, I mean, this is gonna be a number in seconds or milliseconds. That's gonna always be greater than 0, right? But then the next spawn time is gonna become the current time plus the time between spawns, which I want it to be half a second, right? What this is gonna do is that you won't be able to run this until half a second passed. So then we can control the spawn rate this way. And let me see, literal float use an F. I keep forgetting. You have to put an F at the end of floats. So now I'm gonna get an enemy every half a second, and I can control it like this. Now we only have 4 minutes left, so I'm gonna show you very quickly how you will implement the avoidance or like the collision, right? So you grab the player. If you want to collide between two objects or detect collisions, either your player or the enemy has to have let me check what it's called again. It has to have a box collider. And in our case, we have a box collider, but it's a 3D one. I'm actually going to get rid of it, remove component, and add a 2D one since we're making a 2D game. Box collider 2D. And then, just 1 second, my bad. Okay, box collider. We also need to add a rigid body 2D. This rigid body needs to be kinematic. So is there going to be an option? Yeah, here, kinematic. What this is going to mean is that physics cannot affect this object. So when the enemy object hits me, it's not going to move me and shove me around. It's just going to go through me. But you need the rigid body to be able to detect collisions, as you can see here. Then in the enemy, I'm going to change the box collider. Can I do it? Yeah, I'm going to change it to a 2D box collider 2D. And then is trigger. So yeah, then we go back to our player movement script. And at the end, you're going to be able to add this function here, just a special function just for handling collisions. On trigger enter 2D collider 2D trigger collider. And then if you would just do destroy game object. What this is going to do is, if anything collides with the player, it's going to destroy the player. At least it should. Collider could not be found. Let me see. Collider 2D. Are gonna help? Yeah, because we had a 2D collider in our player. So if I run this, we should be, yeah. And that's it. We got an hour, but we were able to make the game. I hope you guys learned something, and I hope it was fun as well. Let me know if you guys have any questions, but yeah. I mean, 1 hour is very short amount of time to make a game. But I hope it was good. Thank you guys for being here. No, thank you guys. See ya. And good luck hacking. Yeah, I'll give you, okay, so follow this channel. There's this series that was super helpful. Game devs. If you follow this series, it's going to be really quick and you're going to go from 0 to a very good place rather quickly. Those are my favorite game dev series. So yeah. Good luck, man.